Well, we got the Eico 625 back on the workbench. We're going to change the cord. I've got some new cord here and a connector. I've done some work to this off camera. I finally got the neon bulbs for it. They finally sent me the right ones. Thank you for sending those. I've changed this resistor, 3.9 ohms. I've changed these 4 resistors on this switch. Changed all the resistors here. This wire wound resistor's fine, nothing wrong with it. This precision resistors, there's not resistor, I don't think there's anything wrong with that one. We'll double check that. And this one I have not changed because I did not know about the neon bulb. The old neon bulb, I don't know if I still have it here. I was looking at neon bulbs and there's a couple of specs on those neon bulbs. One of them was that it requires a 2000 ohm resistor or a 200k resistor, I can't remember, but it said it needed a resistor in line, and I looked and it was to keep it from burning the neon bulb up. So here's the old one that's busted. The filaments are still in it, right? So I think how this worked, it's a neon bulb, so these the electricity charges the gas and it starts to glow. So I checked the resistance from the ground to the tip. It's clean to these. There's no internal resistor in this, and you can get any 51s with an internal resistor or no resistor, so it would use an external resistor. So I got the bulbs, the NE51s that require no resistor, no external resistor in line, and it's in a series, right? It's not in parallel, it's in series. And if you look at this resistor over here, that's on this switch, that's on this bulb, it is in parallel with the bulb. So this is internal to this this machine, to this bulb tester, in conjunction with the capacitor that I changed. And this was a 0.01. The other Eico had a 0.005. So I did have a 0.01 capacitor that I changed. We'll double check this real quick to make sure. And this resistor, I believe this resistor does need to be changed. I think it's out of tolerance. I just hadn't changed it because I wasn't sure. When I did these resistors, I didn't know about the neon bulbs, what they required for resistors, and I thought maybe this was the resistor for that bulb, but apparently it has something to do with how that that short light works on this. I have changed these cables to or electrical wires to those grid cap connectors. I forgot that I had test lead, that I had made test leads. I made test leads for my vacuum voltmeter and for my other digital, for this one. For this meter. I made these leads. I bought these connectors and I made these leads. And this is that soft, pliable, it's test lead material, so it's meant to be moved around constantly. So this is probably the best material for these grid cap connectors. So I'm very happy with that. It was not that hard to change. The hardest part was this one is at this connector here, and it's routed underneath this transformer where all these wires are. It was kind of a pain to do, but not that bad. It wasn't that hard at all. And this one was a breeze. This one was real easy. Yeah, that's where we're at. I did clean the test push button switch. I ran some electrical contact cleaner through it. No issues with that. No issues whatsoever. I think I will get the meter over here and we will check that. We will check that resistor. I'm going to have to pull up the schematic. I don't have the schematic in my hand. So I'm wondering where I could put this where you can see it. I know that is hard to read, but I'm going to need some room to work. Yeah, you can read that. I'm going to need some room to work as well. Not that you need to see somebody checking resistors. Oh, come on. Don't be like that. There, you can read that. Let's get my leads straightened out here. So there's no bulb in it, in that socket, so the only thing it's going to read is the resistance across that resistor. So let's get this hitched up. Oh, come on, really? What did I do wrong? Oh, I know why. In the wrong mode. Let's double check this, make sure the meter's working. Yep, meter's working. I'll make this as easy as possible, but no, I gotta be an idiot and screw around here. You still read that? Yes. Oh, how hard can it be to check a frickin' resistor, huh, you big moron? You big dummy. Come on. Is there a bunch of melted... Oh, that... When they... Whoever had this before me had... I think they used liquid electrical tape to hold the bulbs into their worn out grommets. So, which I thought was really funny. So there's no place to really hook that. So let's just change this, quit screwing around. This cannot be rocket science here. So 500, 480, that's in the M range? Come on. We're clean there. 4.8. So that's 488K. 488K. And green is 5. And brown, that looks like brown, so that would be, or orange. Orange or brown. Orange would be 2, or red. If that's brown, then that's 1. So 51. Let's see what the schematic says. Let me pull up the schematic. I should have been on this before. I'll be right back. Alright, the schematic calls out R7 for the resistor across the short light. And that's a 500K. I don't think that was ever brown or black. So 51 is what it originally was, but it's a 20% resistor. So, and it's low, it's not high. It's 488K. So 500K times 0.8. It can be as low as 4,000K or 400. Yeah, 400. 400K. I don't know why my tongue is being twisted up like that. It can be as low as 400K, so we do not need to change this resistor. It's a 20%. There is no gold band on it, no silver band, so it's a 20%. So it cannot be that critical. So we put a bulb in it and a grommet. Let's go ahead and put that other lead back on this and check that resistor. I guess we have to pull this. I think that's a 96K resistor. I'm going to have to look in the schematic closely. Come on. Quit fighting me. It's good it fits in there tight. That means it hasn't been out a whole bunch. Nobody's been in here monkeying with this. Just this monkey. Me, I'm the monkey. I think that's 96K, but let's look real quick. Let's see which resistor that is. It sits across. What the heck? And it goes out. It's in between the switch and the short light. Yeah, R6. R6. It's 96K, 1%. That's a 1% resistor, 96K. Oh, I don't know if I have a... And it looks like a pretty good size one, too. 1%, so this has got to be really, really close. Oh, what are you doing? Why are you not working? What is your problem here? These clip-ons, sometimes you got to wiggle them to make good connection. Screw this. I'm not screwing around with those clips anymore. I'm sick of them. 97. So 1%, that's way out of tolerance, I believe. That's supposed to be 96K, 95K. It could be 95, 95. Boy, that one is really, I should be changing that. What, I got a different reading now? Before we had a 96. Alright, this is going away. So 97. Yeah, that's way out of tolerance. I'm going to have to see if I have a 1%. I guess it doesn't have to be a 1% long as the resistor I put in there is within 1% of the 95K. I'm going to have to dig through my resistors. I made a big, I bought resistor kits. I bought 2 resistor kits. I got 2 watt and 1 watt resistor kits. 2 watt and 1 watt resistor kits. I bought electrolytic kits, the electrolytic kit, and a capacitor kit, and some big heavy resistor kits. These things come in handy when you got those the bigger resistors in the radios, you know, those I think they're anything that's 2 watt. I don't know. There's some 3 watt resistors that I've ran into. It's also nice to have those if it's going to be a power resistor. It's going to be, you know, burning down some voltage. It's nice to have those big 5 watt resistors. Let me dig through the resistors and see if I have a 95K resistor to replace that with. And I'll get it changed, and then we'll be back and put the bulb in it and a grommet. And I think we'll be ready to test this bulb tester after we change the line cord, after I do the line cord. So you might not see it until after I... Definitely not going to see this again until I get the line cord changed in that resistor. Alright, we'll see you in a few minutes. Well, I got the new power cord soldered on, the knot tied in it in the right spot. I did not put the end on it yet because it's got to go through the case. Pardon me. I did not have a 95K resistor, but I did have a 75 and a 20, and they added up to be 95. So sometimes you have to do that if you ain't got the right stuff. If you don't want to wait or don't want to run somewhere for a, you know, a 3-cent part, it's no big deal to put 2 of them in series together and then put them in place. So that's what I did over there. Let's see if we can get a little better look at that for you. Yeah, you can see what I did there. I put 2 of them together. So that's the way it is, and that's the way it's going to be. It doesn't have to be a 1% resistor. It's just got to be 95K within 1%. Now over time, I don't know if those will change, but that you know, those other ones, that other one did, so I guess it don't matter all that much. So it measures the right thing, and I had to do the same thing over here too. I didn't have this resistor. I don't remember what size it was, but I was able to put two of them together to make the right size. They must be oddball size resistors. I'm not going to worry about it too much because it's right. It's got the right resistance here and the right resistance over there. So I think we're ready to put it back in the case, and we'll get the case over here and take a look at the paint job I did to it and put the handle back on it. Be right back. I'll get the case over here and I'll get this off the bench for a second because we're going to need the room, right, for the case. Well, here's the case. I painted it with hammer paint. I think it looks really good. I like the way this paint looks. I know it's kind of hard to see, but I like the way the paint turned out. It looks really good, I think it looks really, really good. I think the paint turned out pretty nice on this. The hammer paint is just awesome stuff. It's got a really cool look, and it kind of matches the blue that's on the front a little bit. I think the colors kind of go together, but I don't have an eye for color very well. You know, if it ain't Ferrari red or jet black or bright white, you know, it's a color. You know, so I'm pretty happy with the way this turned out. We'll put the handle back on it. The handle's not in that great a shape. It's pretty rusted, but I don't have a blasting cabinet, you know, and the way to take this apart, and actually, you know, I don't know. It kind of lets it down that it's all rusted. I guess I could tape it off and paint it. I don't know. It's just a frickin' handle, man. It's just a tube tester. Nobody's ever going to really see it but me. I like things right, but I don't know how I would replace these rivets. I guess I could use machine screws to replace these rivets, drill them out, and then if I got, you know, I got it away from the plastic, I don't have a blasting cabinet, but I could hit them with a wire brush and then put some rust stopper on it, you know, the converter stuff. I don't know if it's worth it or not. Maybe in the future. I don't know. We'll see. I'm okay with it myself. I mean, it doesn't look, you know, well, looks like crap. Let's be honest. It looks like crap. But I'm going to put it together the way it is. I'm okay with it. Maybe in the future, if I could find some rivets that I could redo this with, I will. Like machine screw, I guess, or I have to think about that. But this comes off real easy. I don't have to take any of the electrical apart. I just pull those face covers and get in there and pull these two screws, and then I can take this apart and work on it. So I think I'm going to just put it together the way it is. We'll put we'll feed the cord through. I'll get a grommet in here, and we'll feed the cord through, and we'll put the end on it. Here's the end I'm going to use. I know I have an electrical connector fetish. This one is just okay. The only reason I'm using it because it's polarized. I don't want to use one of my really nice, and it's narrow too. Those other ones that I have are round, and when you're have a terminal strip, you know, like a power strip with the switch on it, those round ones, you can't put two of them side by side. They take up too much room. So these flat ones are better. They go in there and you can put another one in next to it. So for test equipment, I think this is the way to go. These are okay connectors. They go together real nice. They're really secure inside. They have a good strain relief system on them. So they're good. And I'm gonna do that, and then we'll get back to it and we will check the operation of the tester. Okay, got the connector installed. Got the grommet put in. The wire strung through. The tester body back in the case. The tester's back in its case. These things are where you can, I made it, you know, so you can slide them in and out as you need them. And these are that test lead material, so they're really nice and supple. They're very nice. They feel good in your hand too. I know this one's broken off here, but you know what? Oh well. As long as you don't turn number 10 on, as long as it's in the center position, there's no power. 9 is for that one. This one's number 9. So each one of these numbers correlate to a pin on a tube, depending on how many pins are in the tube. So up to 10 pins. I don't know if they made tubes with more than 10 pins. I don't know. But most of them I deal with have 8. Some of them have 6. But most of them have 8 or the octal design 8. I haven't done any loctals, but that might be coming up here pretty quick. I got some portable I got a portable battery operated Philco that I'm going to do here in short order. I don't know how long before I get to that one. Let's go ahead and plug this in. Turn the variac down. It's on bulbs. I got it on 2 bulbs. So this is on. Let's turn this up to about 80. Let's start at 80. Make sure this is on. It's drawn at 0.07. Is it on line adjust? Line adjust. I know we don't have a tube in it, but that'll tell us if that rectifier tube's working though, I think. 0.06 amps. Yeah, so it's working. We'll go ahead and crank this up. There's 117 and it's drawn 0.09. So I'm going to bypass the dim bulb tester. I think this is supposed to have 117 to it. Can we adjust it? We can. And is that... That's pretty good. Alright, we'll get a tube. So the shunt... So the shunt looks like it could be adjusted maybe a little bit. Yeah. Let's try and adjust that. Do I need... Can I do it with this screwdriver? Or do I need to get my precisions out? Looks like I'll be able to do it with this. So I kind of want that right on 0. It may have a cut in there where that screw is. Okay, right on 0. So when I come around, is that on 100? It's right on 100. So this is going to be accurate. So this is going to be pretty accurate. So when it's all the way down, it's on 0. When it's all the way up, it's all the way on 100. I might edit that part out. I don't know if I got my head in there or not. Probably got my head in the... Alright, filament is on 50 right now. So as this thing warms up, more and more over this is going to go, right? It's drawing 0.09. Let's probably warmed up enough. I think we have that 50L6 that the other one said was shorted. I'm still not convinced about that, but we have a 50L6 we can test that we think is bad. So let's roll this chart to a 50. See? It gets loose. I don't know how that happens, but it gets loose in there. There's no slippage of anything. It just gets loose in there on the one roll that you're pulling it to. I messed around with it and I think by moving it and stuff, it just kind of comes undone somehow. I don't know. Maybe it's not connected on the one end anymore. I didn't take it all the way to the very end. Am I going the wrong way? Yeah, I'm going the wrong way. Sitting there talking, not paying attention. Okay, there's 35, 50. 50 L6. So shunt is 17. See how worn this is around here? Somebody's really thumbed this a lot. 17. So there's 15, 16, 17. Alright, so shunt's on 17, 50 L6. And this is on 50. Let's make sure that's right. 100, 70, 50. SEL is on 3, but we'll leave that on line adjust right now. 50 L6. Well, maybe we'll put it on 3 for right now. 50 L6, 3, and then up is 3, 4, and 5. 3, 4, and 5 are up. 50 L6, 3, 4, and 5, and 2 and 8 are down. And 2 is underlined. Oh, that's really loose. I don't know if that's making contact with all of the pins in there. Huh. That's disappointing. Doesn't fit in this one, right? Yeah, it is this one. So this guy has been used a lot. That's... We'll see if it's making connection though. Line adjust. I see the filament in there glowing. I don't know if you can see that or not. That filament's in there glowing. So it's making connection on the filament. Line adjust. So it's drawing 0.23 amps right now, which I would expect with this. Let's check shorts. So 2 is the one you don't move, it's underlined. 50 L6 is 2, so we can move 3. We're gonna check this short light because it's new. So the short light does work, it comes on. No short, no short, no short. Yeah, it does the same thing. So there is something wrong with this tube. Yep, something wrong with that tube. So there is something wrong with that tube. So the machine does the same thing on the other one, and we tested that other 50L6 that was in this box. So we know this guy's bad. So there's no reason to test him any further. So I'm glad about that it did the same thing as the other one. I feel better that this tube is actually bad. So I'm going to keep it for the base in case I ever want to make a solid state power supply. I've got an octal base. I can turn into a with diodes, right, and a resistor. So I can, you know, if I ever need I know those 35Z6, no, Z5, Z4, they're getting expensive. They're like 20 bucks for a rectifier tube. They're getting real expensive. Or it's a 30Z5, 30Z4 or whatever. You can get a 30Z3 if you don't need the center tap for the bulb for like $5. But you can also go up, I think, in voltage. Instead of I think you can step up to like a 40. a 40 volt one. 40 or 45, I don't remember. I remember looking online and seeing that. Well, anyway, this appears to be working. We can grab another tube out of that radio that we're working on right now. I'll go grab one of the tubes out of that. Maybe the maybe we'll check a rectifier tube, the 35, the Z5. It is Z5, isn't it? Z5? 35 Z5, 35 Z4. I'll grab it out of there real quick. Let's see, rectifier tube is gonna be this one. And I think that's a good 50 L6. And here's the good, this is a 35 L6. Let's check a 35 L6. And then we'll check a 35 Z5. 35 Z5. So 35 L6. So 35 L6. So let's go the other way. We need to go to 35. 35 L6. 35 L6. 35 L6. Shunt goes to 20. 32 for our voltages. Let's turn this on. Let it be warming up. So 3, 4, and 5 are up. 3, 4, and 5 are up. 2 and 8 are down. That's the exact same thing as that other one. Huh. 35 L6. Just the only difference is the voltage for the filament. So let's get this guy in here. See him start to warm up. You can see the filament starting to glow on that. And this is out of that that 74 WG1510A, that airline radio we've been working on. Let's go line adjust. So we got to bring this back quite a bit. Okay, I think we're there on the line adjust. Back to 3 on that. Okay, 2 we don't move. So no bulb. No bulb. Yeah, no, the bulb doesn't come on there. And yeah, we know that we tested this one on that other tester. And I think it was up in this area here somewhere. Wow, this one's showing even higher. I'm okay with that. It's good. So let's go ahead and pull this out. I can't believe how loose that is up there. I might have to take this back apart and tighten those sockets. I should have tried those before. Turn all of these back to the center position. Okay, so this is a 35 Z5. I wonder if this is even in here. $35Z5. It's a 35 Z3 you can get for $5, but if you want a 35 Z5, it's 20 some bucks. And the 35 Z3 just doesn't have the center tap for the bulb. So if your radio or whatever you're working on does not need the center tap for a bulb, then you can use a 35 Z3. Okay, so what are we setting this to? We're going to be on 32 because it's the voltage. Our shunt is going to be 35 Z5 is going to be 17. So 18, 7, 17. SCL's on 3. The only one that's up is 5. And 2 and 3 are down. 2 and 3 are down, and 8. 2 and 3 you don't move. They're both underlined. So we can go ahead and throw this in here. Let that start warming up. You can see the filament glowing in there. A little bit high, not bad. Let's turn that back down just a little bit. Get in line here with it so I can see. Okay. Put that back on 3. And we'll see. I wonder if it's going to be in the week. Nope, good. So, there. The Eico 625 is up and running. Without a calibrated testing tube, I guess, then there is no way to know if it's correct or not, right? There is no calibration. The resistors inside the machine are the calibration. We just want to check to make sure that the short light works, and it does, because that's probably the most important part to this tester almost, is this. Your circuit overload is going to protect the machine, right, itself, if one of the tubes is drawing too many amps but not shorted, or if there's something internally wrong. So overall, I am pretty happy with this purchase. It was a little more work than I wanted to do to this, you know, repairing this. It was kind of cool, though, to take it apart and see that date in there. I thought that was really neat. And the other one, right? This is a 52. The other one's a 54, 1954. Be happy with this, right? Everything's going to be just fine. So turn this off before I forget, you big idiot. I might tighten those tube connectors, but as long as it's working, I don't know. It's nice to be able to just slide them in and out of there without having to fight it. So if that's, you know, if that's the way it works, then that's the, as long as it works, I'm happy with that. I wonder if I should get a bulb out that uses one of these to test this. Well, I'm not going to worry about it right now. We'll cross that bridge when we get to it. If I have to take it back apart, I got to take it back apart. I got another one down there that I know that works, or I think that works. You know what? I never zeroed this. Well, I don't think it's going to throw it off that much. So, well, we'll recheck this 35Z5. Screw it. Just because, right? So, let's see. This has got to be on 3. We got to be on 32. This has got to be on 17. 35Z5, 32. SCL's on 3. 5 is up. 2, 3, and 8 are down. I'll set it over to line adjust. Let it warm up for a few seconds. I don't think zeroing that needle is going to really make that much of a difference. I think more than anything, you want to make sure that it comes back to the same spot every time. Why are you not coming? Oh, duh. You got to turn that back on, you big idiot. Okay, we got 117 volts there now. I suppose if I didn't have this bright light on, I would have noticed these lamps not coming on. So we'll let this warm up, because we did not, I don't think I moved this. I may have. 35Z5, we don't have to worry about shorts, we're more concerned about the meter. Oh yeah, didn't really change it that much, did it? Well, that's funny, it comes to a different spot. Okay. Well, I guess we'll call it good for now. The handle, it has a handle. The paint's still a little bit wet up here, a little bit soft. I think we're okay with this. Thanks for watching, and leave a comment down below and let me know what you think of the tube tester and overall how the videos are. Your opinion counts, so thanks for watching again. We'll see you in the next video. There's one more feature to this that I did not mention on the other Eico 625, is there's a bulb tester, a light bulb tester right in the socket here. You got to know what the voltage of the bulb is, but you set your filament voltage to the bulb voltage. So I've got a 47 here, which I believe is a 6.3. It's a lamp. It's a pilot light lamp for the dial light for a radio. For most radios, a lot of the radios use this 47. I've got the I've got power hooked up onto it. It's turned on. So this is hot. There's 6.3 volts sitting here, and I'll try and do this so you can see it. Yep, you can check your bulbs right there. I think that is a neat little feature to this. Well, it's pretty cool anyway. It's an added bonus. So if you have any doubts without using a, ohm meter on your bulb, you can always turn your bulb tester on, set your filament voltage to the correct so it won't even fire. Barely comes on, and that's 2.5 volts. So there's 5 volts. 6.3 would do 7.5 for a second. Yeah. So there it is. Thanks for watching, and leave a comment down below.